Alright, this is part 2. Oh man. Alright, number 8. Car moving at a speed of 8 meters per second. Enters a highway and accelerates at 3 meters per second squared. So the car is initially moving at this velocity. Okay. At this speed. And accelerates at 3 meters per second squared. You see the per second squared. So meters per second squared, that's acceleration value. How fast will the car be moving after it has accelerated for 56 meters? Well, it ends in meters, so you know that's your distance. So how fast will the car be moving after it's accelerated for 56 meters? Well, it kind of wants you to figure out, well, what is my final speed after it's traveled that distance? So you're solving for your final speed. Okay, solve. Which formula has all these 4 variables and which formula is missing t? Which one is missing t? Has all these 4 variables. It is going to be vf squared plus equals to vi squared plus 2ad. Alright, that's your formula. That's the formula you're going to use. Number 9. Car increases speed from 9.6 meters per second to 11.2 meters per second in 4 seconds. So it's going from this speed to another speed. You know its speed because it ends in meters per second. So if it's going from one speed to the next, it's going from your initial velocity or speed to your initial velocity or to your final velocity or speed. So initial velocity is going to be 9.6, 11.2, and it says in 4 seconds, so you know it's going to be 4s. So the average acceleration of the car during this 4-second interval, that's what the problem wants you to find out. It wants you to find out what your acceleration is. Solve. So what are you missing? You are missing D, which formula has all these variables and is missing D. Well, VF is the VI plus AT. Okay? Now, number 10. 10. The speed of an object undergoing constant acceleration increases from 8 meters per second to 12 meters per second. And it's going from number to number, and it ends in meters per second. So we know it's going to be initial velocity, 8 ms, to vf, 16 ms. Okay? So t is going to be 10 seconds. So it says in 10 seconds. So how far does the object travel? You're trying to figure out your distance traveled. What variable are you missing? You're missing a. Do you need a to solve for this problem? You might need it. But again, we can use average velocity, d over t, vf plus vi over 2 is equal to d over t. Okay? So vf plus vi, 16 plus 8, 24, 2 d t. Oh, we do have t. So 12 is equal to d times 10 over 10 times 10 on both sides. You get 120 meters. Almost forgot my units. So it is 120. So the answer is C. Because 120 is 1.2 times 10 to the 2. So 11. car traveling west in a straight line on a highway decreases its speed from 30 meters per second to 23 meters per second. Again, it's going from number to number. It ends in meters per second, so you know it's a speed of velocity. So if it goes from number to number, it goes from 30 meters per second to 23. You know that's your initial and your final. In 2 seconds, the problem wants you to find out your acceleration. The car's average acceleration during this time interval is what? And then we're missing D. And we don't need D to solve this. Which formula has all these four variables? Well, we know VF to VI plus AT. This problem is a little bit tricky, so I'm going to solve it with you guys. So your final velocity is 23, 30 plus A2 minus 30. So you're going to get negative 7. It's going to 2A. And you're going to get A. Again, divide 2 on both sides. Divide 2, divide 2. Negative 3.5 meters per second squared. Now, what does negative mean again? Negative is a really important concept in physics. We know that negative is the opposite direction of the positive. What's the positive direction in this problem? The positive direction is the west. So what's the opposite direction of the west? It's going to be east. So negative 3.5 in this problem can also be interpreted as 3.5 meters per second east. So it's going to be A. Again, the positive direction in this problem is west, as labeled as such. 12. 12, 12, 12, 12. Car accelerates uniformly from rest at 3.2 meters per second squared. Saying from rest. From rest, well, my initial velocity is going to be 0. 3.2 meters per second. And again, that's acceleration value, so you know your acceleration is 3.2 meters per second squared. Travel the distance of 40 meters. Its speed will be, so it wants the final speed. It wants you to solve for this. What are you missing? All right. You're missing T, which formula does not require T, but has all these formulas. I mean, all those variables. You're going to have this. The VI squared plus 2AD. And you just solve for VF. 13. A boat initially traveling at 10 meters per second. So it already tells you, again, meters per second is a velocity or speed value. Accelerates uniformly at a rate of 5 meters per second squared. You see per second squared, you know that's going to be your acceleration. You know your time is going to be 10 seconds. So how far does the boat travel? You want to find out D. Solve. So what are you missing? You're missing VF, which formula does not require VF, but you have all of these. You're going to use this formula. That's when you're going to use to solve it. Number 14. An airplane originally at rest. It says originally at rest, so you know that's 0. Initial velocity 0. Accelerates uniformly at 6 meters per second squared. That's an acceleration unit. 6 meters per second squared for 12 seconds. 12 seconds. During this 12-second time interval, the airplane travels a distance of approximately what? How much approximate distance of travel? Well, that's what we're solving for. Solve. So which formula are we going to use? Again, we're missing VF. missing. So which formula is missing VF? But we have all these four. Use this one. Easy formula. That's how you're going to solve everything.